a business and some of the architectural choices that come with trying to make a business grow over time. So scaling business is inherently difficult, and ensuring your technical architecture evolves at the pace necessary to meet your business needs is equally as challenging. Together, we're going to evaluate different architecture choices made during different stages of growth in an operation or a business. And we're going to look at that to make sure that they match with the actual needs of the business and are suited from a cost perspective as well. So who am I? My name's Dale. I've spent the last 15 years in tech, from the time where individual services and servers served every different application within your stack. I've worked on physical servers, I've worked on co-located hypervisors, I've worked on cloud computing software that grew from about $200,000 in annual revenue to 50 million in the last year when I left that company. And today I work with DigitalOcean and our site reliability teams to scale the DO cloud. So first, I'm going to talk about different stages of growth within an organization and the way that it progresses through there. At the bottom here, I really want to point out that the early adopters and early stages of growth have a huge tolerance for failure because they're going to take the most recent thing and they're going to be excited about it. Think of your early customers as the ones that are buying CDs in the 1980s when there's a limited selection of things available for them. I'm going to really highlight the section in the middle that is crossing the chasm. So as your operation moves from early adopters to mainstream customers, those customer needs change during that time. And I want to make sure that our architecture is evolving to meet those customer needs. And then I'm finally going to highlight some of the sections at the end here where you've got a stable operating business and how you craft your architecture can help support that and make it a better operating business through time. This content is from Mind the Gap, a book reference there, and it's really based on some research that was done in the 1970s. And you'll commonly see it referenced in things like Simon Sinek's Start With Why, and it's usually how we evaluate different stages of growth and customer profiles. I really want to make sure that we make the leap from the customers that want the latest stuff to the people that make the customer that really want complete solutions. And that leap is as painless as possible. There's always going to be pain. There's always going to be difficulty. But during that section, we really want to make sure that we're adopting and adapting in the right ways. So who's this talk for? We really want to be speaking to those that have seen some pain and growth and seeing your architecture needs change, but also seeing the people that might be looking at something new, starting something new, and thinking about how they can get a leap up ahead and minimize some of that change during that stack. When I talk about architecture, I'm going to bucket this into three high-level categories. One is the language. So I'm thinking here the code language, the actual way that you're writing applications. I'm thinking about the runtime. So this is physical servers, VMs, serverless functions, app platform, hosted on Kubernetes, those different types of options that you have to serve requests. And finally, I'm thinking about the structure. So this could be a single application. This could be a monolith. This could be something that scales horizontally or vertically. This could be adopting a microservice architecture, any different option within that. So first, I want to talk about early market innovation. And this is when we first come to the table with a new idea. We're building a new product out there. We're really trying to capture those early adopters that align with your vision and want to see you grow in that space. Those early adopters tend to have deeper pockets and be much more tolerant to failure because they're going to get the latest things. They really see how your solution aligns with a larger vision and are going to support you within that growth. We often have pivots at this stage of a growth as well. So this, YouTube started as a video dating site. Twitter was for finding and subscribing to podcasts. It's common that businesses in the early stage either don't succeed or may change what they're actually doing. So we want to make sure that from an architecture standpoint, we're supporting that ability to pivot as best we can. So to jump back to my structure here, I'm going to talk about the language, the runtime, and the structure for each one of these different stages of growth. So jumping into early adopters, what does their language look like? Well, really, you have a specific job to be done to start with. You should pick a language that best supports the development of that initial function that you started with. It's really popular to pick a language that you really want to learn or explore as you're starting a new venture. But I'd suggest you pick something that's comfortable, and not just comfortable for you, but comfortable within the circle that you have supporting you. You want to make sure that you can hire and expand your team, and typically that comes from within your network. So while it might seem like it's fun to start a project in Haskell, or it may be really interesting to do some work in Rust, if you're going to build this as a business and expand this, you want to make sure you pick a language that you've got connections to, that you've got deep-seated roots to, you understand the libraries and tools, because that's going to relieve a lot of that stress as you start to grow and you need to lean on those things more to expand your network. You also want to make sure the language you choose is suitable for the problem at hand. There are some languages that are extremely performant. There are others that are great for quickly deploying things or for data analytics. You want to make sure that what you choose fits the problem at hand well and can make sure that it scales with that. Thinking about the runtime for early adopters, it's common to put workloads into existing systems to do this. You may already have a droplet spun up. You may just deploy into that to start with. You may end up with a box running in the corner and just use that to start with. What I'd suggest at this stage is minimizing the time spent on scaling down the road. If you have to vertically scale your application and restart it to add additional resources or redeploy it to a different location, that's a sign that your architecture isn't working properly to scale. So one of the considerations I'd really push for when you're starting an application is look to ship it to something like an app platform. The less time that you spend securing, patching, scaling your app, the more time you're going to have spent on those customer-facing features that are necessary to get those adopters, to hit those early access customers, and to grow into the mainstream here. An example here is Snapchat. They grew on an app platform to the point that they had 220 million daily active users. Up until 2019, Snapchat shipped entirely to Google's App Engine platform and used their managed databases under the hood. They didn't scale their own applications until they got to that point and then started to make it more of a self-managed solution and break into microservices. Another suggestion I'd make at this early stages is to leverage SaaS solutions where you can. There's a lot of plugin solutions for things like monitoring, for collecting of logs, for doing identity and access management. And most of those have a pricing model that is freemium or easy to get started with without spending a lot of money. You can plug in and offload a lot of the responsibilities early in your development setup with those freemium models, and that'll accelerate your focus on what you actually care about, which is your customer experience and your growth there. So don't be afraid to use those. And the structure of your application. It's really popular right now to be structuring applications in a microservice architecture and doing a lot of focus on isolation of concerns. But I'd suggest if you're starting something new, that you really consider putting it into a monolith. The monolithic model is going to save you in context switching. It's going to save you in the ability to navigate that project. And it really doesn't start to hit scaling until you add multiple teams or multiple specific languages or other problems down the road. So early, it would be a premature optimization to start with something that's using microservices or distributed deployments here. Another suggestion I'd have is avoiding multiple deployments where you can. The availability that those early access customers and early adopters need is quite a bit lower than the general public. So you're probably fine to ship to a single location, a single cloud region, a single cloud. Oftentimes we get caught up with the early optimization of, I need to have this distributed. I need to have this across multiple clouds. What if this goes down? So those are not the biggest problems for causing issues within your application in early stages. And we can optimize those later on if we actually get traction and if we actually start to get customers building up there. So consider using a monolith as a model and consider where you ship that to as a consideration for how you scale. As that business continues to grow, we're going to start to move out of the customers that are the early adopters and just get it, and into the people that are the more the mainstream. And they're looking for much more complete solutions to solve problems. Their tolerance is going to be much lower for failure, and their tolerance for payment is going to be much lower as well. They want software that's going to get something done, but at a value proposition that may not be the same as the first people that adopted your product. These are really the people you need to listen to as you continue to grow, because their experience is going to be reflected of your ability to continue growing. Oftentimes at this stage, growth becomes in almost a hockey stick nature up and to the right. It's unpredictable when it's going to hit, and you're really not sure what the user behaviors are going to be when they catch in here. So flexibility is something that you really need to keep in mind with your architecture to be able to adapt to that change in user loads. So thinking about this from a tech profile, what does it look like? Well, the language. You may at this point start to move out of one specific language in order to be able to customize or deal with certain workloads that are a little bit different. An example of this, I worked in an organization that primarily used Python for coding and deployed that to Google App Engine for years. One of the feature sets that we wanted to build was the ability to have live Twitter searches come in. And for example, if I was a locksmith business, I would be able to actually see live searches for somebody locked their keys out of their car in their environment. So I wanted to be able to build a system on that. there's two basic ways that you could get information from Twitter at the time. One of them is to query Twitter and pay on a per request basis to search for those things. The other one would be to listen to everything happening on Twitter and filter it yourself. Well, because we don't know when these come in and time is important, the ability to query Twitter just doesn't work. But to listen to all of Twitter also doesn't really work on Python and App Engine. Being able to move the workload to Kubernetes and being able to run it in Golang suddenly gave us an application that was much more performant and less resource intensive to filter through everything that's happening on Twitter, and we could make a cost-efficient solution for that. So as you continue to grow, you may find spots where the language just makes sense to change. You may also find things like a statically typed language is needed to reduce bugs in some cases, reduce type errors, reduce frequency of incurring those with our customers. So consider switching the language where necessary in specific areas as you continue to grow. The runtime may also continue to change here. So, if you're manually expanding VMs as your way of growing, you may want to consider something that can expand more dynamically. You may want to consider a larger pool of resources that has the ability to auto scale within it. The scaling characteristics of an app platform generally allows you to expand dynamically, and then you can put off some of those architectural changes later once you get the customer momentum and you have a large enough base to justify investing that kind of money. This is also the part where you start investing in maturing your process and your interactions around your runtime. You may want to start building a sandbox environment or building some of the staged CI/CD pipelines to release in order to better mature that release cycle and better mature that experience for the customer. Because as these customers become more mature, they're going to have issues with stability, and you want to be able to make sure that you're shipping a stable product that they can build their business on, and they'll in turn spend more money with you. And finally, the structure. You probably at this point have a growing team. You may have multiple teams. You may have teams specializing in specific areas. That monolith of everybody working together in a single project may start to show some cracks here in the ability to scale. Let's say you introduce a new language. You're probably not going to do that within the same repository structure. So this is primarily where we see the first decomposition into microservices start to happen. And when you need to be able to scale independent units, when you may have different profiles of resource consumption, maybe RAM heavy, maybe compute heavy, those are all spots where you start to think about where I can break these things out. You really want to be specific about where you break things out because you're going to introduce new cultural pieces, ramp up times, understanding how different interfaces work between different services. So as you start to decompose, that's a spot where you can start to see some of those opportunities to become more cost efficient and also scale. You also want to make sure that you define your interactions between services. The more things that you deploy in services, the higher the chance that you're going to have a customer failure or experience. And when you have a lot of dependent services, that tends to be a recipe for more common failures as well. So you really want to define the contract that goes between those different services and start to gracefully handle degradations in there. One of the approaches for this is a lot of queuing systems. So if you've got a system requesting to another one, put those through a queue so they can scale independently. You can slide kind of the rate of the processing in there. You can get a higher utilization of your resources as they talk to each other. As you move towards the mainstream market, this starts to really open up different opportunities than some of the earlier cohorts. The customers here are much less tolerant for failure. They expect things to be up all the time. They're oftentimes picking software as a commodity or to solve a specific problem. And your business model really has to shift to being capital efficient. As you start to see that crossing the chasm, that's oftentimes where venture capital funding comes in and businesses are burning in order to grow. As you become a mainstream player here, you're expected to be able to make money and adjust your model to be able to handle those. So how does that actually happen? Well, you're making language choices based on the challenges at hand. You may introduce 2-3 different languages with specific functions. An example here, I was once working against a Google API for AdSense. Ads in Google were all written in Java. It didn't make sense to try and make a Python or a Golang language choice in trying to interact with those endpoints. The SDKs were just better in Java, and it made more sense to do that abstraction on our side than it does to work against their library piece. We may also be optimizing much more for performance in this space. So this is where we are trying to reduce the latency, reduce the wire costs of applications, reduce those operational loads. And that may lead us down the road of actually choosing different languages that are necessary to do that. Maybe the serialization cost of Python is just too high in a lot of cases. Well, we can replace that with something a little bit more performant there. We really want to become more flexible in our workloads. So our workloads that we started with that we're running and potentially containerized are now probably hosted in something like a Kubernetes cluster that has tighter packing of workloads. We're really trying to push that limit of how tight we can pack things, how we can run them in a multi-tenant environment and utilize more of those underlying resources to become more capital efficient with them. One really good example here is that Basecamp recently announced that they're leaving the cloud. So they have such a steady growth rate at this point that they no longer have to pay the premium of a cloud provider. They're able to predict where they're going, and they have a 12 to 18 month lead time, so they can order additional hardware and actually build out their own data centers at a lower overall cost at their scale. Predicting your growth brings in a number of opportunities to optimize. You're then able to do things like committed spend discounts with providers. You're able to negotiate longer term contracts, and you're really able to become a more profitable organization at this stage. That's really what we're looking for here, is a decoupling of the cost of running your application from the day-to-day incremental increase in number of users added to that. So with each 1,000 users, for example, the next 1,000 users should cost less to add to your application. You're really taking care of economies at scale here. What do we see from a structure standpoint? We're probably making real investments at this point in platform engineering. We're making business-specific tooling to keep consistencies between applications and keep teams consistent. This could be standardizing our CI/CD or our software delivery system. It could be managing microservices through command lines, through infrastructure as code investments. We're really focusing on how our scaling our customers and serving our customers at scale. At this point, we probably also see the opportunities to optimize for efficiency, using lower cost resources, offloading backend or bulk processing to things like spot instances or preemptible instances, things that have a lower CPU cost in there. And we're probably driving a lot of tooling growth. You'll see this is a shift to open source tools. This is a shift to replace any of the SaaS solutions that you picked up earlier because they have a lower cost, and we have the available cycles. Now that we're changing our software less and trying to find that product market fit less, we're able to continually evolve and grow there. So kind of in review here, there's no right or wrong way to grow, and there's no real single approach that fits all businesses and solutions. Some of these pressures may come earlier in your cycle, and some of these pressures may come later. Sometimes you may be forced to make technology choices when you're just not quite ready, but other times you can delay them and consciously delay them in a way that it allows you to focus on your core business here. I've got a few minutes left here at the end for some questions, and I did see one come in here around app platform security. Can you restrict access to the data and the code? And is that basically like shared hosting? So when I think about app platform, I think about you shipping a containerized application into a hosting environment. Now, each one of those is sandboxed typically so that you have access only to your own code that's run on those small machines that are delivered there. So you don't have to worry about being shared from the perspective of somebody else having access to your underlying data. And typically they come with a number of benefits in there. Some of that might be a DDoS protection pieces. The underlying hosts that are being hosted on are likely a Linux or something like that has protection on it and routine patching and updates. They generally also don't live long enough where the point of being a wide attack vector happens as well. So if you've got a machine up for a long period of time, there's a better chance that somebody could get access to that or negatively influence that. So there's a number of benefits from it from a features perspective. The downsides are you tend to have whoopses in cost. If you're scaling dynamically in an app platform, there's the perspective that it could scale horizontally, and the only thing that's going to limit it is how much money you have to pay for it. So that tends to be a risk in there as well that needs some type of a management around it, whether that be spending limits or tight looking at graphs of your cost daily. Making sure you can manage that spend over time also makes sense. So I have about 5 minutes left here. So if there's any other questions, feel free to pass them to the moderator and I can take a look at those as well. I will make myself available within the within the Discord channel afterwards if you've got other specific questions or want to talk through scenarios. I think that'd be a lot of fun. Great. So we've got a question that reads, we're in an early stage startup in a market where a product is necessarily distributed. Do you think it makes sense of using multiple cloud platforms to serve early stage problems, or is it never justified? The distribution question is really interesting because there are solutions that solve well for distributed systems. It also adds a lot of complexity. So we're thinking likely there about needing some type of a global load balancer in order to be able to route to your local locations. In the case like that, I think I would still try and pick a single cloud provider that's able to provide that solution for you. One example of a great distributed database that may or may not work for it is something like Cloud Spanner. It's globally distributed and it solves a lot of the issues across syncing data and keeping data with eventual consistency issues. It does tend to be expensive on the order of I think 90 cents a node an hour. So it does tend to be expensive in that regard. But sticking with one provider to do that allows you to go deeper within that suite. And over time, as you continue to grow and have a larger spend with them, you're able to negotiate some of those details versus trying to pick an AWS in South Africa because they're located there, or DO in Australia, or Google in North America. You don't want to try and get across those accounts because it comes building for the lowest common denominator of technology, but then also having to manage all of those different bills and those different permissions and those different deployments. Great. It sounds like that's a wrap here. I think I'm the last speaker of the day. So hopefully this hasn't been an overwhelming amount of content for you and that there's been some value in there. I'm looking forward to the discussions in the Discord channel afterwards. And I appreciate you taking the time to listen to my opinionated views on what you should do with your systems and architecture.